All right, we're going to take a look really quickly at some special right triangles. The first one we're going to take a look at is the 45, 45, 90 right triangle. Again, all the things we're going to talk about today are proven using Pythagorean's theorem, and the beauty of these special right triangles is you can know one side and you can get the other two sides very quickly by knowing the simple properties. These are used in, I always use the example in class when I took drafting and design and then mechanical drawing and things like that. The two triangles that you use in those classes are a 30, 60, 90 triangle and a 45, 45, 90 triangle. For just this reason, if you know one side, you can get to the other sides very quickly. One thing we should note about an isosceles right triangle, how do I know if it's isosceles? Well, if they're both 45, I can use the converse of the isosceles triangle theorem to say if these two angles are equal, these two sides have to be equal. That's the two sides that make up the right angle, which we're going to call the legs. Now I'm just going to call both of these A. And then the hypotenuse we're still labeling as C. So in this case, I could now come up with an equation using Pythagorean's theorem. A squared plus A squared has to equal C squared. A squared plus A squared has to equal C squared. Looks like class is over. Now we're getting ready to start next period. But so now when I look at this, if I said, all right, let's solve this for C. So we're going to define the hypotenuse in terms of the legs. Well, if I simplify this expression, I'm going to get 2A squared equals C squared. And if I said solve this now for C, I can take the square root of both sides. Square root of C squared is C. The square root of 2A squared, I can break that down into the square root of 2 and the square root of A squared. 2 is not a perfect square, so that has to stay under the radical. A squared is a perfect square, right? The square root of A squared is A, so an A is going to pop out, and we're left with root 2. So the hypotenuse in terms of the short leg, or I'm sorry, in terms of the leg, there's no short leg here, is the leg times root 2. So I like to think of it this way. If I want to get to the hypotenuse, I can multiply by root 2. In the same sense, if I knew the hypotenuse, so let's put that over here. So C equals A root 2. If I knew the hypotenuse, though, and I wanted to get back, this is sort of like if you think of order or when you're solving an equation, to move something from one side of the equation to another, or get rid of an operation, we're always doing the opposite operation. So if we multiply by root 2 to get there, to get back, we're going to divide by root 2. So I know it looks a little messy, but let's just clean that. So now I could start making problems up. Let me erase this stuff in the middle right now. And say, if I know the leg, if this was 6, this would be 6. To get here, I multiply by root 2. So if this was 6, this would be 6, this would be 6 root 2. Let's suppose I make this square root, or let's make it 3 root 2. If one leg's 3 root 2, again, the legs are congruent. The other leg's going to be 3 root 2. How do I get from the leg to the hypotenuse? I multiply by root 2. So in this case, C is going to equal the leg 3 root 2 times root 2. Well, what's the square root of 2 times the square root of 2? Whenever I multiply a radical by itself, in a sense, we're canceling out the radical symbol. So root 2 times root 2 is 2. I still got to multiply by its coefficient. So I get 3 times 2, and I get C equal to 6. So again, I know one side. That was really quick. 3 root 2. That's 3 root 2. 3 root 2 times root 2 gives me 6. The other types of problems you're going to see with this is where they give us the hypotenuse. If I start off knowing the hypotenuse. So let's suppose I know the hypotenuse is 8. Now I want to get back to the legs. In this case, we're going to divide by root 2. And really, you don't have to know the divide by root 2. If I know this formula, C equals A root 2, plug in what I know. So I know C is 8. And now if I said solve that for A, we would just simply solve this equation for A. We're going to divide both sides by root 2. They're going to cancel out. I can't leave it as 8 divided by root 2. I got to simplify it. We can't have a radical in the denominator of a fraction. So we're going to rationalize the denominator. To rationalize the denominator, we take whatever term's in that denominator, and we're going to multiply that fraction on the left-hand side by root 2 over itself. In a sense, we're multiplying this thing by 1, which is why we can do that. If you multiply something by 1, it's not going to change. So now, 8 times root 2 is going to give me 8 root 2. Root 2 times root 2 is going to give me dos. And then that simplifies, right, to 4 root 2. If this leg's 4 root 2, guess what the other leg is 4 root 2. So again, knowing the special properties of the 36 or the 45, 45, 90, going from the legs to the hypotenuse or from the hypotenuse back to the leg, can be done rather quickly.